My name is John Balbus. I'm a Senior Advisor for Public Health to the Director of the NIEHS, Dr. Linda Birnbaum. And the first thing I want to say is Dr. Birnbaum sends her regrets. She would have liked to be here to greet you this morning. This is a topic of great importance to her, but her schedule did not allow it, so I start by just sending her regrets. But I'm very happy to be able to welcome you in the room and also everybody on the web who's viewing this to this meeting and to really express our pleasure on behalf of NIEHS to be able to co-sponsor this important meeting with the EPA and Dr. Cote, who we'll hear from next. I want to thank the Planning Committee for putting together a really amazing agenda today. This is going to be a very exciting meeting, and also make sure we recognize the work that Dr. Marilee Shelton Davenport and Aisha Ahmed have done in making this meeting happen today, and thank them for their excellent work. So today's meeting is really the next step in what's kind of a long, deliberate march. It's a march that expands upon the risk assessment process that we've had for many decades that relies primarily on the interpretation and the extrapolation of rodent bioassays. And we're kind of marching to, with a lot of steps along the way, a predictive toxicology process, a different kind of process that takes advantage of the speed and the high throughput of more modern toxicologic techniques, the modern molecular, cellular, and lower order animal assays. We're trying to do this because we have a lot of chemicals out there that need to be tested. It's very slow and expensive to do it with the rodent bioassays. We're trying to come up with a system that's more comprehensive, allows a more comprehensive screening of chemicals. And ultimately what we're trying to do is to create a better system of public health protection from chemical hazards. I've personally had the honor of working with the National Research Council on two earlier steps in this march. One of them was the Committee on Toxicogenomic Technologies for Predictive Toxicology. The other was the Science and Decisions Silver Book. And so we've seen firsthand that the translation of this new toxicology and the translation of systems biology, what we're going to be talking about, into dependable, reliable, reproducible predictions of toxic hazards and public health protection is harder than it sounds, and at least to me it sounds pretty hard. So this is a long process, it's a deliberative process, and it's why it's so important that we have meetings like this where we step back, take stock, convene the best minds in the field, and make sure that both the science and the practice of public health protection are aligned, moving in the right direction. At NIEHS, the National Institute of Environmental Health Sciences, and the National Toxicology Program, we don't perform risk assessments ourselves, but we do try to inform them, whether it's through working on the molecular mechanisms or studying highly exposed populations or actually trying to pioneer the high throughput assays themselves. Our work is supporting public health protection in part by informing the risk assessment process and the regulatory process. Our participation in the Tox 21 initiative is one big example of that, working with the Chemical Genomics Center of NIH and the EPA and the FDA. And our support of this committee, the Emerging Science for Environmental Health Decisions Committee, and this meeting today is also an important part of what we try to do at NIEHS to inform the process and to ensure we have the best public health protection possible. So I hope you share my excitement for today, for what we're going to hear, what the questions we'll get for the kind of discussions that we'll have today. And once again, welcome you on behalf of the National Institute of Environmental Health Sciences. And now I want to welcome Dr. Ayla Cote to the podium to give her welcome.
Thank you. I want to echo John's thanks for the National Academy of Sciences and the Planning Committee, which have all worked extremely hard. These are not easy events to put on. Unlike John, I'm not going to talk about science much, but this is a golden opportunity. I'm going to talk about me. And the reason I'm going to talk about me is I think I'm somewhere between an object lesson and a parable, a cautionary tale about the future of environmental risk assessment. About 3 years ago, I was asked by my boss then, Peter Proust, to begin to look at how molecular biology could inform risk assessment. And initially, I didn't want to do it. I said, it's way too early to get into that. And for those of you that know Peter, he can be a quite persuasive guy, particularly if you work for him. And So I launched on this effort and started reading the literature, and it wasn't very much longer where I decided it wasn't that we were too early, it was perhaps we were quite late in beginning to think about change. That while I had not been paying attention, the world of biology that I grew up in had changed dramatically. So I think the first point I'd like to make is you often hear that it's too early to begin to incorporate these kinds of data into risk assessment, but I actually don't think that that's correct. I think the time is now to begin. The second point I'd like to make is I've done nothing else. I'm a well-trained, experienced, traditional toxicologist, and I've been doing nothing but looking at this kind of literature over the last 3 years. And I still miss important technical details and nuances of papers. I'm usually enlightened by someone young enough that doesn't remember when genomics wasn't a word in science. And so that I think one of the things we have to keep in mind while focusing on the science, that some of the major barriers to change are going to be both re-education of the existing environmental risk assessment community, as well as building the infrastructure that allows both senior and young people that are well-trained and well-grounded in these new disciplines to infuse the sort of traditional area of environmental risk assessment with their new knowledge. And then the last point that I would like to make is that change is going to happen, I think, whether we lead it or not. That the amount of money that's being spent in clinical medicine, personalized medicine, pharmaceuticals to treat disease at a molecular level, I think change will happen, and we're all going to be much happier with ourselves if we help lead that change as opposed to watch it occur. And I think that we can bring a lot to the table, a different perspective in terms of the application of this new information that if you're in clinical medicine may not be immediately obvious to you. So as you know, and there's, I think, real progress being made collaborating with the clinical community. I know many of you are aware that for the first time in a long time there's going to be a new study section, NIH-funded study section on, I think we ended up calling it systemic biology, but I mean the real emphasis is on the merger of these clinical knowledge, the new molecular computational biology with existing toxicology. So I think the future is bright, but I think, again, make the point that change is upon us, and it behooves us all to attempt to lead that change or participate in leading that change. So with that, let's start our exciting new endeavors.